Thomas Edison, the inventor of the light bulb, once said, we now know 1,000 ways not to build a light bulb," after his fascinating discovery in 1879. Light, it's all around us. Humanity relies on it more than you can imagine. You don't realize how important light is in our everyday lives until you have to change a light bulb that goes out, or on that dreaded moment when the electricity goes out and you're forced to use candles and flashlights. There are many technologies that provide illumination for our homes and businesses. One of the oldest forms of technology, and the most commonly used, is the incandescent light bulb. These are all around us. We've grown up with these light bulbs. However, due to changes in legislation and mounting economical concerns, and a growing energy demand that must keep up with production, energy efficiency has become a main priority. As an electrical engineering student and employee at a consulting engineering firm, I deal with this issue on a daily basis. One new technology has been deemed by many to be the future for lighting is a device called an LED, or a light-emitting diode. So what is an LED, and how does it work? What are the benefits from using this technology, and how is light in general produced? Well, light is everywhere. The biggest contributor and the most natural, of course, is the sun, but next is technology. And how is light in your home generated? Light is not so much generated, but it's actually converted. Our light fixtures are responsible for this conversion. How well the light fixture can convert electrical energy into light energy is called its efficiency. Many common technologies today, such as incandescents and fluorescent bulbs, produce light, but they also generate lots and lots of heat. This heat is essentially lost energy in the conversion process. This is one reason why you can't touch a light bulb when you go to change it while it's being on without burning your hand. You have to wait for it to turn off and cool down. However, LEDs do a very efficient job of converting this electrical energy into light energy, or photons. They're actually cool to the touch when turned on. So how does this mystical LED bulb work? Well, an LED is a basic semiconductor device, meaning it has electric application between a conductor and an insulator. Its two conductor materials is a p-type material, which contains positive holes, and an n-type material, which contains negative electrons. And as electrical energy is connected to this device, these positive holes and negative electrons are attracted to one another. And as they become close together, they collide. And much like in a car crash, or you have an explosion or a wreck, when these positive holes and negative electrons collide, you get light, or photons. And depending on the types of material used for this conductor, you can obtain different colors and variations of light. For instance, in commercial buildings, white light is more common, which is produced by fluorescent bulbs. And in residential buildings, incandescent bulbs are more common, which produce a yellow light. This makes LED a viable replacement for all light bulbs. So what are the benefits for using this technology? Well, when comparing lighting technology, there are really two main points to look at. One is the efficiency, or how well the electrical energy is converted into light energy. And second is the life of the device, or how long it can illuminate before it burns out. In both areas, LEDs far outshine the competition. In a study published by the government at EnergyStar.gov, LEDs are 75% more efficient than incandescents and 25% more efficient than fluorescent bulbs. The other two technologies, or bulbs, use electrical energy to produce light, but also produce excess amounts of heat when heating up gases or heating up resistive elements to produce light. LEDs, however, use semiconductor materials to create a conversion where most of the energy is produced as light energy instead of heat. This also impacts the life of the device, because as a device is hotter, its parts tend to fail and not last as long. And another study done by EnergyStar.gov shows that LEDs last 25 times longer than incandescent bulbs and 10 times longer than compact fluorescents. So are you now ready to go out and buy your first LED bulb? maybe not, but hopefully now you have a better understanding of how LED light bulbs work and their contributions to our lives and how light in general is produced. You now know that they have a longer lifespan and are more efficient and can possibly one day be the future light source for our world. Next time you catch a glimpse when you're in a building and you look at a light fixture or you're changing a light bulb in your home, you can refer back to this knowledge and have some viable information. You'll have a better idea of how something so relevant to the functionality of our homes and the production of our workplace operates. As J.R.R. Tolkien once put it in The Fellowship of the Rings, may it be a light to you in dark places when all other lights go out. Thank you.